In this video, I'm going to give a full information about MQTT protocol. It is one of the most important protocol of IoT. MQTT stands for Message Queue Telemetry Transport Protocol, and it was introduced by IBM in 1999. So MQTT is a lightweight protocol. Lightweight in sense message packets have less number of fields. Size of the message packets are smaller compared to HTTPS, and it is also called by the name called Publish Subscribe Network Protocol. So in this video, I'm going to cover these many topics with respect to MQTT. So first, I will give the information about the MQTT components. Next, I will start with MQTT methods. Next, I will give the information about MQTT working module, and next I will tell about the topic. Next, I will tell about the message format, the fields which are there in that message format, and last I will give one picture that is called by the name called the data flow in MQTT. So let us start with the first topic, that is MQTT component. So the first component of MQTT is a publisher. Publisher is nothing but the sensors here, right? Sensors will publish its data onto the network, you can say. The first component is publisher. The second component is subscriber. So subscriber is nothing but the applications which are interested on sensors data. And the most important component is broker. So broker is acting as a central point okay, and this broker is used to connect the two above components, that is publisher and subscriber. That means this broker do the connection between the publisher and subscriber. Whatever the data which is published by the publisher by the sensor, it will be transferred to the respective subscribers. So if I take this publisher, it will generate the data that will be published. The published data will be transferred to this subscriber with the help of the broker, which will be the intermediate component between the publisher and the subscriber. So this is about the MQTT components. Now let us take the next one, MQTT methods. I'm going to prepare my slides by explaining. So the first method that we have in a MQTT is connect. So connect is a method. It is used to connect the server with the client. It is used to connect server with client. Next one is disconnect. So it is used to disconnect after the work of transmission or receive is done. Next, publish. So publish is a method, uh, whatever the data is available, that data is to be published. And for that we are using this method called publish. And last one is subscribe. So subscribe is the one, if a client or application is interested in the data of the sensor or a publisher, then subscribe method is used by the client to the broker. Okay, so these are the methods that we have in a MQTT. So connect method, it is used to connect the server with the client. Disconnect method is used to disconnect the transmission or reception after the work of transmission or reception is over. And publish is the method, whatever the data is available, the publish method is used to publish the data onto the network. And subscribe, if a client or a application interested in the data of the sensor or a publication, then the subscribe method is used by the client to the broker. So now let us take a picture to understand how actually the flowing of the data takes place. So let us take this diagram. Okay, here we have a three different components. The first one is MQTT publisher, the middle one is broker, and the third one there are three clients: client one, client two, client three. Okay, this example. Uh, Here MQTT publisher is nothing but the temperature sensor that I have taken, and in between there is a broker and one of the most important component of MQTT. And here we have three clients: C1, C2, C3. So as I said that the message will be transferred from publisher to these clients with the help of this broker. So let us assume that this publisher is nothing but the temperature sensor here, will publish the data. Say for example, it is publishing 25 degrees Celsius. So let us consider it is publishing the data 25 degrees Celsius. So here I will write 25 degrees Celsius. And this data will be published, and this data will be taken by the broker. So publish method is used here. Next, this broker, what it does means it will maintain a queue here. It will maintain a queue inside broker. So here there will be queue like this. In this there will be queue. So whatever the data that will be published by the sensors, publishers, that will be taken inside the broker. And this broker, the main work of this broker is to give a published data to the respective clients. That too, when if these clients are very much interested onto this particular data, that is 25 degrees Celsius with respect to this example. Say for example, C1 is very much interested in order to take the data 25 degrees Celsius. So before going to uh, give a 25 degrees Celsius data to the client, first the client has to be subscribed to this particular uh, component, that is broker. So let us assume that C1 is very much interested, and it will the C1 will give one message to the broker that I am very much interested to take this particular data. So that is called by the name called subscribe. That is called by the name called subscribe, which will be done by the client. So here I will write one subscribe. So when subscribe message is received from the client one to the broker, and whatever the data which is available in this particular broker, that will be given to the client like this. So this will be given like this. So it is called publish. It is called publish. So like that, if C2 wants the data and C2 wants to data from this particular publisher, say for example 25 degrees Celsius, first C2 has to send the message to the broker to subscribe, and then broker will give the data by publishing that data to this client too. And like that, C3, if C3 wants to take the data that is 25 degrees Celsius, again a subscribe publish communication has to be done. So all these communications will be given by the broker by maintaining the queue. So this is how the actual working of this MQTT is done. Part of the broker, that is MQTT topic. So this topic is maintained by the broker. So what I said is while doing the communication between the publisher and the clients, in between there will be a broker. This broker maintains the queue. That queue is nothing but the uh, topic. So this topic is maintained by the broker. Broker maintains all the topics which are necessary for the uh, communication between the publisher as well as the clients. So what is the meaning of topic? Topic is nothing but the routing information. Routing information, that is, it will tell what is to be routed from publisher to the client. So here we have certain methods in order to route. So let us take one example. I have a home. In that I will take a hall. In that I will take temperature. So this is one simple topic which tells that I am going to take the temperature of the hall with respect to the home. This is called a simple topic. And if I write like this, home slash, I will remove hall now, I will write plus, and I will write temperature back. So what it tells is, plus symbol tells that it is a single label wildcard. Single label wild card. The meaning is, plus tells the meaning that it may be a temperature of a kitchen, it may be a temperature of the bedroom, it may be a temperature of the hall. That is, this plus is acting as a single label wildcard with multiple attributes. So I will replace this hall by plus symbol. Plus is nothing but a single label wildcard. The plus may be, it may be a hall, it may be a bedroom, okay, it may be a kitchen, like that. And next what I will do, I will write one more, home slash, I will write hash. Now hash is nothing but multi-label, multi-label wild card. So it will take all the information, plus a symbol tells that it is a single label wildcard, plus maybe the temperature of a hall, plus maybe the temperature of bedroom, plus maybe the temperature of kitchen. That is multiple, it works on the multiple attributes with respect to the temperature. And if I write home slash hash, hash represents the multi-label wildcard, If I write hash, it will take the whatever the thing, it may be a temperature, it may be a something else, all the information about the home will be taken by this wildcard. So this will be maintained inside the broker in order to transfer the data from publisher to the clients. MQTT message format. In this we have certain fields like message type, dupe, QoS, retain, remaining length, variable length, payload. And in fixed header present in all MQTT control packets, variable header present in some MQTT control packet, payload present in some MQTT control packets. Now let us see one by one. Message type. In MQTT we have 14 different control messages are available that I will give about that information in the next slide. And each message type has a unique value that is contained into the message type field. That varies in between the 0 to 15, and those are reserved. The next field the next field is DUP. DUP is nothing but duplication message. This flag, when set, allows the client to notate that the packet has been sent previously but an acknowledgement was not received. If it is equal to 1, then it will notate that the packet has been sent previously but acknowledgement was not received. Then about QoS, we have three levels of QoS: QoS 0, QoS 1, QoS 2. I will tell about that in the next slide. Next, in about retain. Retain flag only found in publish message. It notifies this particular field. This notifies a server to hold on to the message data. This allows new subscriber to instantly receive the last known value without having to wait for the next update from the publisher. The last mandatory field is remaining length. It specifies the number of bytes, this one. This specifies the number of bytes in MQTT packet following this field. Variable header. Variable header field will find in some of the message field, and payload is the data that is to be transmitted from the uh, publisher to the clients. So now let us take the QoS. As I said, here there is a field called QoS. In QoS we have three levels: QoS 0, QoS 1, QoS 2, quality of service. So QoS 0, here we have a publisher, in between there is a broker, and the last one is subscriber. So how it works is the publisher sends the message to the broker only at one time, and from broker it will be sent to the subscriber, and there will be no retransmission and there will be no acknowledgement. That is called QoS 0. In QoS 1 we have again publisher, broker, subscriber. So here message delivery between the publisher and the server, and then server to subscriber, occurs at least once. If the message is not acknowledged, here the message is not acknowledged, it is sent again. It guarantees, this particular QoS one, it guarantees at least once delivery. And in QoS 2, neither loss nor duplication of the messages are accepted. So this is about QoS. And as I said here, in message type we have 14 different control message types, naming from 0 to 15. We have these 14 different messages. The first one is it starts from, actually it starts from 0 to 15. Here they have given 1 to 14. So first message type is nothing but the connect. So connect, if I write the value of this particular message type is equal to 1, then it resembles that there is a flow from client to server. The meaning is request to connect. Like that, if it is equal to 2, then connect acknowledgement, server to client connect acknowledgement. And if it is equal to 3, then publish message from client to server or server to client. Next, public acknowledgement, it may be a client to server or a server to client. Next, publish received, it may be a client to server, a server to client. Then publish release, it is a value 6. If I write with the value of 6 in message format, it represents that publish release, it may be from client to server or server to client. And next one is publish complete, it may be from a client to server or a server to client. Then subscribe request, it is from client to server. Then subscribe acknowledgement, it is from server to client. And if it is equal to 10, then unsubscribe request from client to server. Next, unsubscribe acknowledgement, it is from server to client. And ping request done by client to server. Next, ping response will be done by server to client. And the last one is disconnect, that is client disconnecting. So these will be the numbers which will be written inside this message type. So this is about the information of message format of the MQTT, that is message overflow. So the same picture that I have taken, that is the first one, there will be a publisher, in between there will be a broker, and the last one is subscriber. So what does the publisher do? It will publish the data, and that data will be taken by the broker. It may be a QoS 0, that is at most once delivery, QoS 1 at least once delivery, QoS 2 exactly once delivery. The data will be taken by the broker. On the basis of the topic, the data will be given to the respective subscribers, that too when they will request. So QoS 0 at most once delivery, QoS 1 at least once delivery, QoS 2 exactly once delivery. So by this, I'm going to conclude this particular video. Hope it will be a very informational video. Thank you all.